Good morning. This lesson is for my Honors Integrated 1 class and for my Integrated 1 class. I don't know what the title of this lesson is going to be. It depends on what class you're in. But what I do know are what our goals are. And we have two goals today. Our first goal is going to be to define transformation, image, and pre-image. Our second goal is going to be to define rigid motion, describe rigid motion, and verify rigid motion. So let's just go ahead and jump into our first goal. A transformation is a function or a rule that changes position, shape, or size of a figure. What we start with is the pre-image, and the result is the image. We often use the term map to describe a transformation. Example of a transformation. Remember, it's a rule that changes position. So here I have a point that has been moved, its position has changed, and I want to talk a little bit about notation. So this mark right here means that I have something called A prime. Alright, and when you have A prime, I'm telling you that we have an image. And since I have an image, I know that we have been moved because the result is an image, which means that the letter without a prime mark is the pre-image. So this is where we started at. So we started from here and we moved to here. This would be my transformation. Now again, a transformation is a very fancy way to say how you move an object. It can move, it can rotate, it can flip. We'll get into that later. But again, this is a pre-image. I know I ended up here. I know I started here. There's no mark. Here, this is where I ended up. There's a mark which we call a prime, and this tells me that this is where we ended up. I'm going to go ahead and hit pause, check off the first goal, and we're going to move into the second goal. It's going to take a couple of takes to get through the second goal. I want to make sure I articulate enough to make it hopefully clear. So let me erase everything, and I'll be back. I'm back. So we're moving on to our second goal, and our second goal is to define rigid motion, describe. I need to learn how to spell. Let me put the red line under there. Describe rigid motion and verify rigid motion. So we're going to define, and we'll describe a little bit of that. So rigid motion is a transformation that changes the position of a figure without changing the figure's size or shape. The this translation means you get the same object in different locations. Okay, you just move it over there, it's the same thing. You spin it over there, it's the same thing. You flip it over there, it's the same thing. All right, those are rigid motions. There are 3 rigid motions. Our first rigid motion is a translation, which is a very simple, very fancy way to say the simple word slide. A translation slides the object. So here's my original object, and I know that it slid over here because I have primes. Still the same shape, still the same size. These would be what we would call congruent. Rotation spins the object about a point. So here's my original object. It is going to spin about this point, and it's going to rotate over to here. I know that this is the image, this is the pre-image because I have my prime marks, so that tells me this is where I ended up and this is where I started. And my last rigid motion is a reflection. And a reflection is when the object, which flips the object over the line of reflection. So here's my original object, and I'm going to flip it over this. Notice that the letter C, or point C, is closest to the line of reflection, and in its image, C prime is also closest to the line of reflection. So when it flips over, the distance from the line of reflection is going to stay the same. I know this is my image because I have the primes, and this is my pre-image because there's no primes, and this is my line of reflection. The line of reflection can be vertical, horizontal, or diagonal. So I'm going to go ahead and hit pause here, erase all of this. I'll be back to describe some more, so I'll be back. I'm back. All right, let's continue with our second goal here. So I want to show you how transformations can be written as a rule. An example would be the pre-image of xy turns into the image of x minus 3 and y plus 4. So I have an example here. If A is 1, 1, and using this rule, we get the following. So let me get it up to this side here. So that means that A, which is 1, 1, gets mapped to 1 minus 3, and then 1 plus 4, which is, I sort of put this, I'm sorry, which gets mapped to A prime, and if we simplify A prime, we get 1 minus 3, which is minus 2, and we get 1 plus 4, which is 5. Okay? And so on a graph, we're going to see the following transformation. So we're at 1, 1, which is A, and we're going to call this a translation, sliding. And we get moved to negative 2 and 5. Okay? So we go from the pre-image to the image using this rule. So you're literally just plugging in the x and the y value into this and simplifying to get your image. Now you also need to create a rule that describes the transformation. So here I'm at negative 2, 3. This is my pre-image. This is my image. And again, I know that I end up here because I have a prime. So we know that B, which is negative 2 comma 3, maps to, or goes to, B prime, which is 1 comma negative 2. So the question is, what do you have to do to a negative 2 to turn it into a 1? And you have to add 3, right? So that means that the xy that we start off with, 2 becomes 1 by adding 3, so that's x plus 3. And right now we're just going to be doing adding or subtracting. And how does 3 turn into a minus 2? Well, that means I need to take away 5, so it's going to be y minus 5. So I explained how 2 turned into 1. That's how x turns into x plus 3. I'm sorry, negative 2 turns into 1. And I described how 3 turns into negative 2, and that's y minus 5. So y becomes y minus 5. This is how we write the rule. Okay? I'm going to come back one more time, and I'm going to talk about how we verify rigid motions. So let me erase everything and set up the last part of the lesson, and I'll be back. I'm back for the last time for this video, I promise. Alright, so let's go ahead and look at this. So our second goal continued. Right now, to verify a transformation is a rigid motion, we need to show that the side lengths are the same from the pre-image to the image. We use a Pythagorean theorem for diagonal lengths. We don't need to use a Pythagorean theorem for horizontal lengths or vertical lengths. It's like I'm TikTok dancing. Horizontal lengths or vertical lengths, because we can count those. Okay, so we only need the Pythagorean theorem for diagonal lengths. So here's an example. We're going to determine if the transformation is a rigid motion. If so, classify it as a translation, rotation, or reflection, and write a rule for the transformation. I know that I started here. And I ended up here because these all have the prime marks and this one does not. So this is where I begin and this is where I end. And so before I'm going to figure out what type of transformation I have, I'm going to figure out what do I have matching side lengths. So to go from A to C, since it's vertical, I go up 1, 2, 3, so this length is 3. Okay. To go from A to B, I go horizontally 1, 2, 3, so this is also 3. Okay. And guess what? I know that this diagonal length is going to be equal to the square root of 3 squared plus 3 squared, or the square root of 18. So that's this diagonal length, right? Remember, I can only use I only need to use a Pythagorean theorem when I'm counting diagonal lengths. So let's look at the second triangle. So go from A to C, I have to go up 1, 2, 3, okay. So these guys are the same length. To go from from A prime to C prime, to go from A prime to B prime, I have to go over 1, 2, 3 as well. So A prime to B prime is the same length as from A to B. And notice these lengths of these legs are the same as these lengths of these legs. And so I can determine that this diagonal length from C prime to B prime must also be the square root of 18. So I know that the side lengths are the same from the pre-image to the image. So I have a rigid motion. This is a translation. It slid. Okay, this is a translation. Now I'm gonna come back and make a video that talks about just rotations and just reflections. But I thought that this would be good just to see translations, and you'll see how we write rules for those coming up here shortly. So I have a translation, which means that I need to use addition or subtraction to describe what I have. So let's pick a point. I like working with A. So we know that A, which is 1, negative 4, is going to map to A prime, which is negative 4, comma 1. So since it's a translation, we use addition or subtraction. So to go from 1 to negative 4 means that x is going to go to, let's see here, x minus 5, right? From having $1 to owing 4, that means you lost 5. And to go from negative 4 to positive 1, that means that you added 5. So y is going to go from y to y plus 5. Okay, so let's see if this works. If I take away 5 from 4, I get negative 1, that works. If I add 5 to negative 4, I get positive 1, so that's working. If I take away 5 from 1, I get negative 4. And if I add 5 to negative 1, I get the positive 4. So this is the rule that I need to describe my translation because I have a rigid transformation. All right, I'm going to go ahead and end this here. Again, I hope everyone is doing all right out there. Have a good day, everybody. Bye-bye.